All right, we're going to walk through all these word problems. We're just going to talk about how to set them up. And I may have taken a few more out than I had told you in the classroom. I don't really remember, but we will see. So I'm not going to actually solve all of these. Otherwise, this video will be forever long. We're going to just talk about how each one should be set up. All right, some of these we've already done, but I don't remember in class which ones we did. So I'm going to just walk through them all. All right, remember, a number is just going to be x. Is means equals. More than or less than needs to go at the end. Okay? I'm already yawning, so sorry. Twice means 2 times. So this is twice a number is 400 more than 6 times the number. That's a lot of words in place. But if we just take this a phrase at a time, twice a number, 2x, is equals 500 more plus 500. 6 times the number is 6x. Twice a number is 500 more, remember that goes at the end, then 6 times the number. That's number 1. Number 2, 3/7 of a number is 24. Of and is, remember of times is equals 3/7 times x equals 24. What number, x, increased by plus 1/4 of itself? So 1/4 times x is equal to 30. Now in all of these, your goal is just to solve for x. All right, so apparently I didn't set this one to come up one at a time, so it's all right here, so we'll just walk through them. Find a number such that. When you have a phrase like that, find a number such that, all that you need to be worried about is after the such that. That's sort of the introduction. 1/4 of the number, 1/4 x, is equals 50 less than. Remember, greater than or less than has to go at the end. So 50 less than, pop that in at the end, 2/3 of the number, so 2/3 times x. Now number 5 is weird, and I know we did this one in class, but I want to go over it again in case you weren't there. So the denominator of a fraction exceeds the numerator of a fraction by 25. The value of the fraction is 3/8. Find the fraction. I obviously forgot to write something in here. And that this should say, I'm going to write this with my mouse, so it's going to look worse than my pen. Equals 3/8. So the numerator is the top, the denominator is the bottom. We don't know what the numerator is, but we know that the denominator exceeds it by 25, so we just have x and then x plus 25. The value of the fraction is 3/8, and then you can use cross multiplication to solve that problem. The number 6. 6 times a number, 6x, is decreased by 6, minus 6. The result is equals the same as when 3 times the number, 3x, is exceeded by 12, plus 12. And then you just solve it. Number 7. If 3 times a number is increased by 22, the result is 14 less than 7 times the number. One phrase at a time. 3 times a number, 3x, is increased by plus 22. The result is equals 14 less than, and where does that less than have to go? At the end. 7 times the number, so that's 7x. Sorry, I had to yawn again, my gracious. Number 8. Separate 84 into 2 parts. We did this in class, such that one part will be 12 less than twice the other. Now here's the thing, we don't know what those 2 parts are going to be. We just know that they're going to be added together to equal 84. So our first equation will be x and y. Here's the thing you have to remember. When you have 2 unknowns, you're going to have 2 equations. When you just have one, like 1 through 7 had, just a number, it was just x. From here on out, most of these, I believe, are going to have 2 equations because we have 2 unknowns. We're going to separate 84 into 2 parts. X plus y equals 84. One part, x, will be 12 less than, so minus 12, twice the other. And then you can use substitution or elimination to solve this. What I would do is I would take, let me get my pencil working or my pen. I would take this value for x, plug it in here, and then just solve it for y. Then once you do that, you can solve for x. Number 9 says the difference between two numbers. All right, I saw two numbers, so instantly I'm thinking two equations. The difference between two numbers is 24. Find the numbers if their sum is 88. So the difference, x minus y, is 24. Their sum, x plus y, is 88. And then what I would do on this one, I would use elimination. I would draw a line right here and I would add these straight down. Because x plus x would give me 2x. Negative y, positive y, that will cancel itself out. And then we'll have x almost instantly. And then you can go through and solve for y. This next one is a little bit strange. There's a couple like this. So it says one number is 3 times the other number. Now that one's not terribly difficult. One number is going to be x. Another number is going to be y. So one number is 3 times the other number. X equals 3y. But then it says if 17 is added to each. That means I'm no longer, for my second equation, going to have just x and y. I'm going to have x plus 17 and y plus 17. So x plus 17 will be my first number. Y plus 17 will be my second number. Okay? The first resulting number, x plus 17, equals twice the second resulting number. So remember, it's no longer x and y, it's x plus 17, y plus 17, because of the 17 is added to each. Now, to solve this, I would use substitution. X equals 3y. I would plug that in for x and then solve. Number 11. The larger of two numbers is 1 less than 3 times the smaller. So let's call x the larger, y the smaller. So the larger of the two numbers, x, equals 1 less than, and where do those less thans need to go? At the end, 3 times the smaller, so 3y. If 3 times the larger, 3x, equals 5 more than, that goes at the end, 8 times the smaller. Find the numbers. And again, I would just substitute that big thing for x in. I would just replace x with 3y. Oh my goodness, I don't know why that went there. I would just replace x in my bottom equation with this right here. I'm using my mouse and not my pen, and my mouse is on my actual computer, so I'm trying to click and draw with my, anyway. That's what I would do, use substitution for that. All right, we did this one in class, I'm pretty sure, but just in case you weren't there, let's go over it. The second of 3 numbers, well, I can stop right there and know that I'm going to have x, y, and z. X will be the first, y will be the second, z will be the third. So the second of 3 numbers is 1 less than the first. The third number is 5 less than twice the second. The third number exceeds the first by 12. So here's the thing. We are told nothing about the first number, so call it x. I don't know anything about it. The second number is 1 less than the first, so y, the second number, is going to be x minus 1. And then I'm told 2 different things about the third one. I'm told 2 different things about z, so set up both equations. And I'm going to have this full thing typed out here, but just hang on for a second. It says the third number is 5 less than twice the second. So 5 less than, so minus 5, twice the second, and I forgot to type the rest of this equation here. See if I can do a 5 on my mouse pad. Not too bad. But because y equals this, I can go ahead and replace that y. And this would be my first z equation. So third number is 5 less than twice the second. The second is y, but we know that y is x minus 1. So just replace the y, and there's my first value for z. Then it says the third number, so this is the second equation for z, exceeds the first by 12, and that first is just x. So x plus 12. Now listen, z and z are going to have the same value, which means this and this are going to have the same value, which means I could have a whole equation that says, except you've got to add this minus 5 here because apparently I forgot that. 2 x plus 1 minus 5 equals x plus 12, and then just solve that for x. Once you have x, let me kind of clean this up. Once you have x, we can find y because y equals x minus 1. Once I know x, I can find z because z is x plus 12. All right, let's get the next one. One number is 4 more than 5 times the other number. Okay. Okay, sorry. My kid walked in and I paused it and I don't know where I was. So let me just start this one over. One number is 4 more than 5 times the other number. If 6 is added to each, the first resulting number is 3 times the second resulting number. So our first equation is just going to be one number is 4 more than 5 times. So one number, x, is 4 more, add that, 5 times the other number. This second equation, though, is where we have 6 is added to each, which means I no longer have x or y. I have x plus 6, y plus 6. The first resulting number, x plus 6, is 3 times the second. So 3 times y plus 6. And then I, again, would use substitution. I would plug that value in for x and solve. Now, when we hit 16, and I didn't set this up to pop up one at a time, that's okay. When we hit 16, the format changes a little bit. This says Jesse earns $6 an hour babysitting for his younger brother. His mom gave him $71 last week. This included his babysitting money and his $20 allowance. So how many hours did Jesse babysit? So we know that he got $20 flat money, like $20, just 20 bucks. So there's my 20. We know that he got $71 total. And then we know that for every hour he babysits, he gets $6. We don't know how many hours he's going to babysit, so we'll just call that 6 times x, x being the number of hours. Okay? And then just solve for x. A lot of these from here on out are going to be comparing two different things. So I just sort of write everything down as I'm reading. Kathy and Carol, or Carol and Kathy, are each saving money for a vacation. Carol started with $25 and saves $7.50 a week. Kathy started with $10 and saves $10 a week. When will they save the same amount? That part right there, the same amount, is important. This is my final formula. When do Carol and Kathy have equal amounts of money? Here's what I know. Carol saves, she starts with $25. So there's my Carol with $25. Then she saves $7.50 a week, but we don't know how many weeks she's going to save. So we're going to call that x. So $25 plus $7.50 times x being the number of weeks she works. Kathy started with $10 and saves $10 a week. So we have that base start plus their $10 per week, and then our x is going to represent how much they make a week. When will they have saved the same amount of money? So all I have to do, because it's same amount, they're going to be equal amounts. So I can say this equals this and solve for x. On these types of word problems, for real, and I just said this, I just write everything down as I read it. So the first thing I read is one weekend, Bill earned 3 times as much as Jim. Bill is 3 times as much as Jim. Tom earns $5 more than Jim. And that 5 should have gone at the end, but that's okay. In all, they earned $60. So Bill, Jim, and Tom earned $60. Now, in order to solve this, I know that Bill is 3 Jim, Tom is 5 Jim, and Jim is Jim. So if I replace Bill with 3 times Jim, I replace Tom with 5 plus Jim, then I can solve that whole set of equations for Jim. Once I know Jim, I can find Bill, then I can find Tom. There's a lot of words here. Okay. The Maxwell children have hired a caterer to provide food for an anniversary party for their parents. The caterer has quoted a price of $96 per person. So that right there is going to be 96 times x, because I'm not going to know how many guests there are. 96 per person, 96 times x. Is asking for an advance payment of 1/4 of the total bill. If the advance payment is $1,200, how many guests are invited to the party? So here's what I have written down. They need 1/4 of the $96, so 96 times 1/4. We don't know how many people there are, so we're going to multiply that by x times the total, and that will give me how many people that there are. 3 children each contributed towards a birthday present for their mother. The oldest, so we're going to have an oldest, and I think I called it the second, not the middle. I probably should have said the middle, and the youngest. The oldest contributed 3 times as much as the youngest. Oldest gave 3 times as much as the youngest. While the second oldest, I did call it the middle, while the second oldest, so the middle one, contributed 50 cents more than the youngest. If the present cost $10.50, how much did each contribute? We don't know how much they all contributed, but we know that the oldest plus the middle plus the youngest came up with $10.50 total. Now we're going to have the same idea here. I can replace oldest with 3 times the youngest. I can replace middle with 50 cents plus the youngest. Then solve that whole thing for the youngest. Then go back and solve for middle and oldest. 21. At a school game, student tickets were 50 cents each, and adult tickets were $1 each. If the total receipts from 900 tickets were $500, how many tickets of each kind were sold? Now, we did value problems quite a long time ago. Remember, we have 2 equations. We're going to have a count equation, and we're going to have a value equation. Our first equation is going to be our value equation. 50 cents per student ticket plus $1 times adult ticket gave us $500 total. Then I know if I add the student tickets plus the adult tickets, I sold a total of 900. Now you guys can solve this several ways. You can use substitution or elimination, whichever one you like the best. If I was doing it, I would multiply the bottom equation by -1, cancel out the number of adults, and then work from there. But whatever method you are comfortable with. This one says a salesman sold 200 pairs of slippers. Some were sold at $6 per pair. The rest were sold at $11 per pair. The total receipts were $1,600. How many pairs of slippers were sold? Now, we don't know which one is which. We're going to just call them X and Y. So then I'm going to sell some for $6. I'm going to sell the others for $11. And there's my 2 equations. Now pay attention to this one because all it's asking for is the amount of $6. So all I need to solve for is X. So if I was going to be the one solving this, I would multiply my top equation by -11. And that would cancel out my Y's and then just solve for X. We skipped 24 or 23 and 24, so let's look at 25 and 26. And I probably should have done these piece at a time, but that's okay. So this says Adam can rent an apartment and walk in the city and walk to work for $6.15 per month. So the city is going to equal $615. He can rent an apartment in the suburbs for $500 per month and take the train to work for $5 per day. So the suburbs is going to be 500 plus 5 times x. And the reason I have that times x there is because I don't know how many days he's going to have to travel. I'm going to call it x. But now the question is, what do I do with that information? And it says, how many days will he have to work per month to make them equally financial or financially equal or whatever that says? So we can just set these equal to 100. Not to 100, to each other. 615 equals 500 plus 5x. And then when I get that value for x, that will tell me how many days he would have to go to work to make those costs the same. And then number 26, a company needs a faster computer to enhance, oh my goodness. A company needs a faster computer to enhance its e-business capabilities. The computer can be purchased for $1,800, $18,090, or rented for $900 plus $90 a month. What is the maximum number of months the computer could be kept so it's cheaper to rent than to buy? So purchase is going to be $1,890. Rent is going to be $900 plus 90 times however month. Now here's the thing. I've got to figure out at what point it is cheaper to rent. So if I set those equal to each other, that will tell me the exact day that your values are the same. So one day less, it would be cheaper. Hopefully that makes sense. So 27 is going to kind of be the same idea in that we need to figure out some information. Jennifer's telephone service costs $30 per month plus 15 cents for each local call. Long distance calls are extra. Last month her bill was $63.50 and it included $18.50 in long distance. So here we have to sort of stop and think for a minute. Her monthly bill is going to cost $30, period. We know that then any local call is going to cost 15 cents. And then she spent $18.50 in long distance calls. So I can take the flat rate of $30, the local call rate, plus the long distance charges, and her bill it was $63.50. So I can set my equation up like this, and then when I solve for x, it will tell me exactly how many calls she made. This one is going to be two different companies we're going to compare. So we're going to be comparing Better Taxi Service with the Best Taxi Service. So Better Taxi Service charges $3 for the first mile plus 20 cents for each additional mile. Best Taxi Service charges $6 for the first 2 miles plus 10 cents for each additional mile. How many miles will a person travel in order to spend an equal amount? Now, we have to think a little bit. Well, it's word problems, we're thinking a lot. But Better Taxi Service is $3 plus 20 cents for anything past the first mile. So we're going to pay $3 for the first mile plus 20 cents for any additional mile. So here's the thing. We are going to pay for any mile past the first mile. That 20 cents does not count for the first mile. So I'm going to have to do x minus 1 because I'm not paying for the first, well, I am. I'm paying the $3 for that first mile. The second one says Best Taxi Service charges $6 for the first 2 miles plus 10 cents for each additional mile. So what I'm going to do is I'm going to pay that flat $6 for the first 2 miles, then 10 cents for any additional. So in this case, I'm going to do 10 cents times x minus 2 because that 10 cents does not count for those first 2 miles. And then it says, how many miles will a person travel in order to spend equal amounts? So just set those two equations equal to each other and solve for x. A video store offers 2 yearly pricing plans, A and B. A charges $10 plus $2.50 for each movie rental. So $10, the flat fee, plus $2.50 times X, because X is how many we rent. B charges $4 for the first 4 movies rented, plus $3 per movie. So the flat $4 rate, the first $4 rate, and then $3 per movie, except remember, we're not going to pay anything extra for those first 4. So I need to subtract 4. How many movies will a person need to rent to equal amount? So again, we set them equal to each other. Just remember on problems like this, when you're paying an initial fee, that when you have a secondary fee, that you take out what you don't have to pay for. And because they're equal amounts, just set those equal to each other and solve for x. Here's number 30. Same idea here. We are going to pay for marina parking versus Main Street parking. You have your initial fee and then your hourly fee, and then set them equal to each other and solve for x. Same thing here. Jamie needs to lease a car. There's your 2 equations, and then you just figure out which is which. Okay? And there you go.